Hello, so today we are going to solve this problem called minimum costs for tickets. So the problem says in a country popular for train travel, you have planned some train traveling 1 year in advance. The days of the year that you will travel is given in an array of days. Okay, so we have a days array, which is days to travel in a year, right? And then train tickets are sold in three different ways. A 1 day pass is sold at cost 0, 7 day pass is cost 1, and 30-day pass is cost 2. So we have an array of costs. And then the passes allow that many days of consecutive travel. For example, if we get 7-day pass on day 2, then we can travel for 7 days. And we want to return the minimum number of dollars you need to travel every day in the given list of the day. The minimum number, the minimum cost, essentially, pretty much. Every day in the given list of days. So example here, we have this days here. So this is the days we need to travel at, and the costs are this. So this would mean that, well, 1 day pass is 2, 7-day is 7, and then 30-day, that's 15, right? Okay. For example, here is one way to buy passes that lets you travel. So day 1 you can buy. So for this, well, you could buy for day 1 at 2, and then covered day 1, about a 7-day pass that covered 3 up until 9. And then day 20, you could buy a 1-day pass that costs $2, and then you got total. Position in days, or it's called current position, and then we will need as well the weather remaining days covered by current pass, right? 0 if none. If we have that, we probably need to know also the previous, either the remaining days like in their values index, or we will need to know the if not in their index, then we will need to know the previous covered day, right? Yeah, I prefer this. So remaining days here, and then index of the previously covered day, right? I think this should be it. So that would give us helper of I, if we have a helper function, and then remaining days, remaining covered, and then we would have the previous covered, right? And the initial call would be 0 covered, and previously covered is none. And then here we can stop when this equals to n. So we are going to try all of them, so we can just try I plus 1, and previously covered is I. Here we could do -1 also, so -1 or none. And then the remaining here, well, we need also the total cost here. So we could either pass that or return it. So either it's cost 0 plus the remaining is 0 here. Okay, so this would be our choice 1. Or starting a new one with cost 1 and the remaining would be 6 days, right? And the previously covered is I. Or we could say cost 2, 30 days, right? And so here we have 29 left, and choice is 2. Or we could also, if remaining covered is bigger than 0, so we have choice 4 here. Let's maybe make this instead choice 4. Let's keep it choice 4. So if the remaining coverage is bigger than 0, then we could probably just do I plus 1, remaining covered -1, and then just passing the previously covered value. No, actually now it's I. I'm thinking maybe if we have a pass, it doesn't make sense to resume a new one, right? So in that case, if it doesn't, then we can just do this if we have remaining coverage. And then otherwise, let's choose the most exhaustive option, and then later we could change that. Choice 4 is going to be that, and then we could return, we want the max, so this is free here, so the max would be among, we want to minimize actually, so this would be the min actually. So to have that be the min, we'll centralize this with F, choice 2, choice 3, and choice 4. One thing here is I'm going to change this here to be choice 1 and make these be choice 2, 3, 4. Okay, I think this should work. Let's try it. return that. Then here we need to return 0. So what should we return here when we are done? 0, yeah. No cost. Yeah, sorry. Yep, actually I didn't check the previously covered because, yep, I need to compare here. And so we need to check that the difference between I minus the previously covered is less than the remainder, right? Because let's say previously covered is 3. So let's say if the previously covered here is 3 and let's say maybe is 6, if the remainder to be covered is just 2, then we can't cover it because we have 3, we have 4, 5 that we can cover, and 6 is not there. So 6 minus 3 would be 3, which is bigger than 2. But if it was 5, then we would have 2, which is equal, which would mean that it's covered, right? So only if it's less than or equal to that we consider it. And then what's the remainder covered? Well, it's I minus the previously covered, right? So that would give us, if this one, let's say, was 4, right? And so this would be equal to 6 minus 3, which would be 3, right? Here, well, this would mean that we can cover 4. So this would mean that we can cover 4, 5, 6, 7. I is 6, it should be just 1 remaining, right? And so here, once we are at I, we should say I minus the remainder to be covered, right? Which would give us 6 minus 4, and then minus 1, because we covered that one. So always take the max of this and 0. Is this correct? What if we had, let's say I is equal to maybe 4 and the remainder is 3, so we should cover 4, 5, 6. So this would be equal to 4 minus 3 minus 1, which would be 0. And that's not correct, right? Because once we cover 4, we should be able to cover 5 and 6. So that's not correct at all. That calculation is not correct. So what we actually need, so we know that so it's actually prev of covered plus the reminder to be covered, right? Minus, so that would give us here 3 plus 4, which is minus 1, right? Which is 7 here. So this is 7, 6, that's correct. That's what we should need to cover. And so with all of this, we need to remove I, right? So this would mean 7 minus 1 minus 4, which would mean 6 minus 4, which would mean 2 remaining, which is correct, right? If we had, let's try another one. So if we had maybe, let's say this was 6, and here we can cover 5. So we have 4, 5, 6, 7, 8, right? To cover 5, right? So this here would be 3 plus the remaining to be covered, which is 5, minus 1 minus I, which is 6. So this would be 8 minus 1, which is 7 minus 6, which is 1. Which is not correct because we need to cover 7 and 8. So it's 3 plus 5 minus 1 minus 6. So this would give us 8 minus 1, 7, which gives us 1 remaining to be covered, which is not correct. Okay. What was for 4 and 3? Well, for 4 and 3, we could cover 4, 5, and 6. Right? And we said here that this is the previously covered, which is 3, plus a reminder to be covered, which is 3 minus 1 minus I. So this would give us 6 minus 1, which is 5, minus 4 gives us 1 remaining. We need 2 actually, so we don't need this minus 1 here. So this leaves us with 3 plus 3, 6 minus 4, that gives us 2, which is correct, 5 and 6. Here, if we remove this and get back where we had the previously covered 3, I was 6, and the remaining was 5, and so we had 4, 5, 6, 7, 8. So with that, we have 8 minus 6, we have 2. So 2, that's correct. So this is what we are looking for, which is the previously covered plus remove the reminder to be covered minus I. And is this correct? So 6 minus 3 is less than or equal to 5, which is correct. So if it's should we do an else here and consider the choices only if Okay, let's debug this a little bit and see what's wrong. Okay, so we start off with 0 and -1, and then we are here, so we take the first choice. We try the second choice. So the first choice has cost 9, 7, and 15. Why is the first choice 9? Interesting. 2, that's correct. Okay, let's try again here by going through the okay, so choice. Then we go to the I equal to 1, and if we take a look at our days, days here, so we are at 4. So we'll try. Okay, so it's 3, 4, 5, 6. So 6 multiplied by 2 should be 12, right? Okay, so we need to be at yeah, maybe let's try with a simpler example. So what if we try just with 1 and 4? Okay, that works. And then let's say 6. Okay. What if we add 7? Okay. 8. Okay. We have our first failure here. What if we just make it 6, 4, and 8, 7? I'm trying to get the simplest example where it fails. Okay, that's better. Let's try 1, 7, 8. Okay, that doesn't fail. Okay, it looks like that's the best we can do here. Okay. Let's add print for helper here. Okay, the other option I want to try here is, so okay, actually I think we need to change the approach a little bit. Instead of passing this covered here, let's do this instead. So for choice 1, we just do that. Now for choice 2 though, we need to do something different. So for this one, next is going to be, since we are purchasing a week pass, then the next is going to be I plus 7, right? And choice 2 is going to be equal to the cost of 1 plus the helper of going to, actually we could just say next equal to I plus 7, right? Because we will do 7 of them. Is going to be next I plus 7. And then if we are going to take the 30 days, then it's, the next one is going to be plus 30. And then the choice is between these. And here it's going to be just 0. And here if it's bigger or equal. Okay, looks like we are off by a little bit. So I plus 1, that's correct. Here we want to process, because I plus 1, I plus 2, I plus 3, 4, 5. So maybe actually 6, right? Because let's say if were at 0, for example, and we purchase it 7 days, then the next one we need to worry about is actually let's say 1. So this means we are covered with 1, 2, 3, 4, 5, 6, right? These are 3, 7, right? So 3, 6, 7 covers 7 days. Because, for example, 3, 4, 5, 6, 7, 8, 9, right? So this would mean that the next one we need to worry about is 8, which is equal to I plus 1, I plus 7, right? So that's actually correct. And the same reasoning for I plus 30 and I plus 1. Is it consistently plus 1? Okay, so take 1 day pass and then we'll go to the next. Okay, and then we take a 7-day past, which will cover us on day 3. Oh, okay, so here we took it at day 3. So we don't need to incur a cost for a day that we don't have, right? So that's the main thing here, because here you can see we took it at 3. So it's not really I plus 1 directly. We incur the cost only if it's, we call helper only if that I is in the array, right? So here we need to say if I is not in days, right? We need to just call the next helper actually we can, what we'll need is kind of to change this a little bit. So this would be day 0, and maybe the 0 index here, but we'll need to do something here. So because we want to try taking at days that are not in the days array, right? Right, so if this is only if I is in S, because otherwise there is no reason to take a cost for a day that is not in the set, right? And then for choice 2, this we take only if days at I is we need to kind of somehow find out if that day is in the, any day in that 7 days interval is in the day set. Is any day in the interval I plus 6 in days, pretty much. That's what we are looking for. So maybe we could do a while. Or next I, maybe let's call it, or next I is less than I plus 6. Okay, seems like this is getting too complicated. I'm thinking to just try the DP, because then it would have been super easy. Let's see, what if I had the DP of I, which would be cost, min cost, ending at I, right? Then I know that DP of 0, which means min cost ending at 0, well, that's just going to be the min. Is the cost array increasing? Not necessarily, so that's going to be just the min of costs, right? And then we could say DP, also DP of 7, right? And we'll need dp of, or let's say dp of I is going to be the min of cost 0 plus dp of I minus 1. And also dp, our dp array here, we need to be initialized ending at day I, right? So our dp is going to be maybe float infinity for all the 365 days of the year. We want 36 because we have 1. So each day we are going to start with 1. So the min cost ending at day 1 bigger than 365, not if it's bigger than n. And now we could pass 1 here, right? The first day of the year, and then, well, here we should not do this instead, but do all of them only if I is in the set. And here we'll send that. Otherwise, we should return just the helper for I plus 1, right? So here we need return. Okay, so that seems to work. Yep, I think that was my problem, that I was ending too early at the length of the array instead of because the values is what I'm looking for, not the indices. Okay, so that seems to work there. Now let's try this one with the same costs. Okay, sounds good. Can we could have length 1, let's try it. What if we had 333? Okay, so now we need to memorize. Okay, so cool. So memo, and here we could do if I in memo, just return, and then here memo of I equal to that. Same thing here, and at the end let's just return it. No return. Okay, let's try with this. Okay, cool. So that seems to pass. Let's run it. Cool. Okay, so this solution passes.